Today, we are taking a trip, a really big one. We're going 15 million light-years from Earth to check out one of the most brilliant galaxies in our night sky, Messier 83, which also goes by the much cooler name, the Southern Pinwheel. But we're not just there to admire the view. Nope, we're going to see how astronomers are using artificial intelligence to unlock its secrets. This is where the future of astronomy is heading.
I mean, just look at this thing. M83 is this incredible, sprawling city made of stars. And because it's a nearly face-on spiral galaxy, we get this perfect top-down view of its structure. It's like we're floating right above a cosmic pinwheel. It's so packed with detail, it's a total treasure trove for scientists. But man, is it a huge challenge to study. And M83 isn't just a pretty face. This galaxy is active. It's cranking out new stars a little faster than our own Milky Way is. And get this, it holds the record for the most confirmed remnants of exploded stars, supernova, that we've ever seen in one galaxy. This place is busy.
So that brings us right to the core of the problem, right? When you're staring at something this ridiculously complex with billions and billions of little lights, where do you even begin? How do you read its history? How do you figure out how it all works?
Okay, first, let's just try to wrap our heads around the mountain of data that astronomers are dealing with here.
Our modern telescopes are absolute marvels. I mean, instruments on Hubble and the James Webb Space Telescope can see galaxies like M83 in unbelievable detail. They give us this absolute torrent of information. It's like trying to take a drink from a fire hose of cosmic data. And that creates a whole new problem.
Exactly. The sheer volume of it all is it's overwhelming. You could have every astronomer on the planet working on it, and they still wouldn't have enough hours in their lifetimes to manually go through and analyze every single star cluster in a picture this rich. The data has literally outpaced our human ability to sift through it.
So, if a person can't do it, what can? Well, this is where the story takes a really cool technological turn.
Let's just compare the two for a second. A human analyst, they're careful, but they're also slow. And we get tired. An AI, on the other hand, it's lightning fast and it never gets tired. It can plow through these massive data sets with perfect consistency every single time. For a job like this, it's not even a fair fight. So the specific tool they used for this job is called a convolutional neural network, or CNN. It's a type of AI that is just amazing at recognizing patterns in images. You probably use it every single day. You know how your phone can pick out faces in a photo? It's basically that. Researchers just trained it to look for a different kind of pattern. Not a face in a crowd, but a star cluster in a very, very crowded galaxy. And the way they trained it is actually pretty genius. To teach the AI what a star cluster looks like, the scientists created about 26,000 fake, or mock star clusters, of all different ages, masses, and sizes. Then, they digitally sprinkled these fake clusters all over the real Hubble image of M83, basically teaching the AI, hey, see this? Find more things like this. All right, so the AI was trained up and ready to go. The team then set it loose on the original, untouched image of M83. So, what did it find?
The results were pretty mind-blowing. After scanning the entire galaxy, the AI flagged 3,380 potential star clusters. I mean, think about that. That's thousands of new candidates that would have been completely impossible for any human team to find on their own. And here's the crucial part. This isn't just a big number. It's a brand new, super comprehensive catalog. It's like the AI just handed astronomers a detailed map to a city they've only ever seen from a distance. It gives them thousands of new targets to study, letting them see the galaxy in a whole new way.
But the AI did way more than just count things. It also figured out the approximate age of each cluster it found. And when the astronomers mapped those ages onto the galaxy, wow, a stunning pattern just jumped right out. There was a clear age difference across the spiral arms. The youngest, bluest clusters are all packed together on the inside edge, while the older, redder ones have kind of drifted away.
Now, what's so incredible about that is that this map is basically visual proof for a huge theory in astrophysics called the density wave theory. The idea is that these spiral arms aren't solid things. They're more like cosmic traffic jams. As gas and dust plow into these slow-moving jams, everything gets squeezed together, and that compression triggers a huge wave of starbirth. The new stars are born inside the arm, and then as they get older, they drift out the other side. This AI's map, it's a beautiful picture of that exact process in action.
So let's zoom out. What does all of this really mean
for the future of exploring the universe.
Well, as the researchers themselves put it, this AI approach isn't just a new tool, it's a whole new way of doing things. It combines finding the clusters, figuring out their age and mass, and estimating their size all into one seamless process. It gives astronomers a powerful, unified way to study entire populations of stars all at once.
And that really leaves us with a pretty fascinating thought to end on. We just saw how an AI could literally read the life story of a galaxy written in its spiral arms. But every single night, our telescopes are collecting terabytes and terabytes of new data from all over the sky. What other incredible cosmic secrets are just sitting there, hidden in plain sight, just waiting for the right algorithm to come along and find them?